Welcome to EDU World Space.
This is chapter 21, problem number 82. Where you're given 2-point charges put between two sheets of charge. One is positively charged, the other one is negatively charged. This is like a capacitor arrangement. And Q1 is given to us as a negative charge, 6.7 microcoulombs, and Q2 is 1.8 microcoulombs. And the distance between these 2-point charges is 0.34 meters. And the electric field generated by these plates, so let me call it E sub P, okay, is 73,000 newtons per coulomb. And we're asked to calculate the net force acting on the first charge and the direction. So, how many forces are directing on Q1 is what we need to look at first, right? First of all, there's Q2. There's going to be Coulomb interaction between the two. Let's try and figure out the direction of the interaction. One is positive, the other one is negative. Q2 is positive, right? So then it's going to attract it towards itself. So let's call this F sub C. Is in the positive x direction, to the right. The other force that we have is due to the electric field between the plates, right? So if we embed a point charge in an external electric field, that is going to generate force. So let's call this force F sub P due to the plates. And let's try to determine the direction of it. So forget about Q1 first. If you have two sheets of charge, one is positively charged, the other one is negatively charged, the electric field that this generates is going to be from the point positive charge towards the negative charge. This is the direction of this E sub P. So now when we embed a Q1 between, well, in this region, the region where we have the external electric field, then there's going to be a force acting on it. Let's call it F sub P. So it's Q1 times this EP, correct? Vectorally. If Q1 is negative, which is negative, then FP and EP are anti-parallel, right? Which means EP, we know it to be for a fact to the right, then F sub P has to be to the left because they're anti-parallel because Q1 is negative, right? So this is FP. Then when we write the net force acting on this Q1, the net force then, FC in the positive x direction minus F sub P, right? So FC is due to the Coulomb interaction between Q1 and Q2. So it's going to be K, the magnitude of Q1 times the magnitude of Q2 over the distance between the two, which is x squared, minus FP, we said Q1 times EP, right? So EP is given to us, everything is given to us, we can calculate the net force. Now K is 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. Q1 times Q2, 6.7 times 10 to the power of negative 6 coulombs. And Q2, these are all absolute values, right? 10 to the power of negative 6 coulombs over 0.34 meter squared minus Q1, 6.7 times 10 to the power of negative 6 coulombs times 73,000 newtons per coulomb. From here, we can find the net force to be 0.45 newtons. It is a positive number, which means the net force is to the right, which means F sub C, the Coulomb interaction between Q1 and Q2 is stronger than the force generated by the plates.